if the leading coefficient was the number in front of the variable with the largest exponent. It leads the equation, and it will tell us how we end on the right. So if we had a negative leading coefficient, it ended down on the right. And because it's an odd degree function, this goes, so it ends up on the left. This one here has a positive leading coefficient, so it ends up on the right. Because it discos, it ends down on the left. So the odd degree functions disco and end in opposite directions. But our leading coefficient sign tells us how it ends up or down on the right. And then our constant at the back we talked about, that was always our y-intercept. And then we said our domain and range were XER, YER. And the number of x-intercepts was 1 no matter what. Because you can have at minimum 1 because it discos. You can have at maximum 1 because it's degree 1. So you can't go any higher. And that was all taught to you in grade 10. Now, normally we would go to the x squared graph, but I'm sticking to the x cubed graph next because it's the other odd function. And odd functions follow the same end behavior. So they end in a disco as well. So the first one we're going to look at, I want you to write this one down, and then you're going to type it into your calculator. So it is y equals negative 2x cubed plus 4x squared minus 3x plus 1. Yep. Okay. Typing it into your calculator. Every single person has a calculator in their hands, and every single person is typing this in. Now I know some people are in different places than others, so I'm going to show you how to type it in. Make sure that you go to your y equals, and we're going to type in negative 2, not subtraction 2, negative 2x, and if you want the cubed, you press this little button, little hat symbol, 3. If you have the older calculators, it'll go hat 3, totally fine. If it bumps up like this, you have to arrow to the right to get it to come back down. So if yours is one that pops up as an x cubed like mine, you have to arrow it to the right to bring it back down, and then type the rest in. 4 plus 4x squared minus 3x plus 1. And then go zoom 6 if your window's set weird. Zoom 6 will help. I know mine's set to negative 1010, so I can just press graph. But you can press zoom 6. So you're going to see a graph in front of you, and it should look like that. Make sure you use negative 2x cubed. Don't put subtraction 2x cubed. And make sure when you have subtraction, you have a subtraction. So this one here needs to be a subtraction, not a negative sign. Make sure that happens. If not, you will get different graphs. Okay, does everyone have that in? You can see it. Now, this doesn't have a max or a min. It actually has what's called a point of inflection. So I'm going to show you what we could do if we typed that one in. So we have it typed in. If I did this, if I was just drawing a graph for my own welfare, I can do this. Let's look at it again. Okay, I just drew that for my own welfare off the screen. And I'm going to do that if I don't actually have to draw one for the test. If I just had to draw one for myself, boom, good, right? If I need marks, if this is on a test and I give you a Cartesian plane and you have to draw a graph, how many marks am I getting for this graph? None. Did I even plot a point? No. So if it's for myself, this is fine. If it's for a graph, we have to use the coordinates from the table of values. So for this one, I'm going to leave it like this. This would get me no marks if I was actually being tested. And then here, I'm going to show you how I properly do it. Okay? All right. So let's look at this graph in front of us. Well, I'm going to do the max and mins first. So the max and mins down here, these can also be called turning point. I hate this board. I have to wait it out. They can be called turning points. So every max and min is a turning point. This graph doesn't have a max or a min. This graph actually has this curve. Oh, the board's going to get mad at me again, I'm sure. No, it didn't. Okay, so this curve here, that I'm making a dot at it, that's actually called a point of inflection. A point of inflection results in no turning points. 0. So that's a point of inflection. A max or a min would look like this. This would be a max, that would be a min. So cubic graphs, just so you know, either look like this with a point of inflection or they look like this with a max or a min. So you're either going to have 2 turning points or no turning points. This graph has how many turning points? 0. So down here I would say max and min, there'd be none. It's called a point of inflection. And that results in 0 turning points. Turning points is a fancy way of saying max or mins. So if you have a point of inflection, you have 0 turning points. If you're someone who wasn't happy with your unit test mark, remember I wrote this in Google Classroom yesterday, that during scheduled help or nighttime, I'm going to be just practicing rational questions with you on the board the whole time, and I'm not letting anyone else in here. So it's just going to be practicing for rationals for the test next week. All right. Okay, what's the leading coefficient of this graph? What is the number that leads this? Because that's what a leading coefficient is. The -2. So I look for my largest exponent, which is x cubed, and I say -2. So the leading coefficient here is -2. You don't have to put it in a box each time. I'm only putting it in a box because I use dashes instead of semicolons. I should have used semicolons because it's going to look like minus a -2 if you go back to your notes. Okay, you don't have to box the -2. Okay. What does the leading coefficient tell me about the graph? Even in your notes, it tells you right in the middle. You should have wrote it yesterday. What does the leading coefficient tell me? Yeah, how it ends on the right, correct? So if this one has a negative leading coefficient, now I'm writing negative LC. Can you write LC on the test? Are you allowed to short form ever on the test? No. Can I short form in my notes because they're from me? Yep. On any test that you're getting marked by anyone in this world, don't short form. So I write negative leading coefficient on a test. Negative leading coefficient. And then because of that, the graph ends down on the right. And our graph does end down on the right. The degree tells me how it ends on the left. So this is a degree 3 function. Because it's degree 3, it discos. Every odd function discos. So if I know that it's ending down on the right and it discos, how's it ending on the left? Up, right? Down on right, and then it ends up on left. So odd degree functions disco. They're always opposite. Even degree functions end in the same direction, and you know that from last year. Polynomial or parabolas, like quadratics, they both end either arms down or arms up, right? Okay. What is the y-intercept of this graph? Without using your calculator, what's the y-intercept? It's 1. Because it's 0, 1. It's a coordinate. So remember that the constant, the number without a variable, is always your y-intercept if your equation does not have brackets. And we went over y yesterday. The reason why is if I'm looking for my y-intercept, I put 0 in for x. This would cancel, this would cancel, this would cancel, and I'd only be left with 1. So that's why the constant is 1. Because if I'm looking for my y-intercept, I plug 0 in for x. So my y-intercept isn't 1. My y-intercept is 0, 1. How many x-intercepts does this graph have? 1. What's the minimum number of x-intercepts a degree 3 function is going to have? The minimum. 1. Why? Yeah, because it's going to end up discoing. At some point I'm going up and at some point I'm going down, and because one's going up and one's going down, I'm going to have to cross through at least one time. I could cross through more, but I have to cross through at least once. Now think about it. I could cross through once like this. I could cross through twice, but I'd have to have a point of tangency where it's where it bounces. So this touches here and here, so that's twice. This is once, or I could have 3. Right? So actually a degree 3 has at minimum 1, but it has at maximum 3. The maximum number of x-intercepts is equal to the degree. So like a quadratic, when you guys did them last year, maximum had 2. It could cross through twice, it could bounce and do that tangent point, which is once, or it could be completely above, which is 0, or completely below, which is 0. Because degree 2 functions, actually arrows are in the same direction, you can end up with 0 x-intercepts. But degree 1 and degree 3, the odds, and that's why I put them together, disco. So at minimum, they're going to have to cross through at least once, right? Those arms are in opposite directions. They have to cross through at least once. Okay, what's the domain and range if it discos? If it discos with a straight line, or it discos with some curves in the middle? I'm still going out for life, right and left, and I'm still going up and down for life, right? So my domain and range are XER. The squiggly bracket means a set of x values such that x is an element of the real numbers, or the set of y values such that y is an element of the real numbers. Every odd degree function discos, so every odd degree function is XER, YER, unless it's a word problem and you get limited. Like, because your x values could be time, right? Well, you can't have negative time, so then it wouldn't be XER. So if it's a word problem, it could change. But if it's just a plain old graph, it's XER, YER every single time when it's on odd degree. Okay. I want you to type this one in. This one we're going to sketch accurately. So we're not going to do this free-handed sketch like I did, which wouldn't get us marks. I hate this word so much. Hate's a strong word, and it's real. So y equals negative 2x cubed plus 4x squared minus 3x plus 1. Type it in. And we're going to be, oh goodness, it is the exact same. It's positive. Sorry. I wanted a positive leading coefficient. Now, on a test, I would have to actually give you graph paper, right? You know, if I wanted it to be perfect, because this isn't going to be perfect if I have to draw text like this. So I would give you like a Cartesian plane. So, I want you to type it into your calculator. So all I did was got rid of that. So this is my graph. Okay, if I press second graph, press second graph. If I press that, I get a table of values. We agree? Are the max and mins on that table of values? Most often they are not, because most often the maxes and mins are little decimals. So before I actually go to graph anything of these, I will always find the maxes and mins first. Now you did this last year. With quadratics, you would have to find either a max or a min. This one has both. So if you look here, this first one on the left, is that a hill or a valley? That's a hill, right? If I was a mountain climber and I was climbing this, is that the maximum I'm getting to or the minimum? The maximum. That's why that's a maximum. What about this one? This one's a valley. If I was a climber and I was climbing down to the bottom, I would be at the absolute lowest I could go, right? So that would be a minimum. Easy to tell the difference. Think about it as if you're climbing up it. Okay? So I'm going to find the maximum first because it's the first one. Now I need to calculate something. Your teacher taught you this last year. I'm just reiterating it. If you want to calculate something, you have to go second and then trace. Why am I pressing second trace? The second button means I'm using the button the word above, right? So if I'm going second trace, I'm actually calculating. Do you see that? That's why I'm pressing second trace. So if I go second trace, I want to find the maximum. So I'm going to press 4. So I want left and right side. Left of the maximum, right of the maximum. So this one says left bound. So I need to be on the left-hand side of it somewhere. So I'm going to hit my left arrow till I'm on the left of the maximum. And then I hit enter. Every single person should be doing this because I'm really good at this, but I do it every single day and I don't do your test for you. Then I need to be on the right-hand side of it. And then I have to, when it says guess, I have to press enter. So write that down to 2 decimal places. That's going to be our max. So we're going to go down here. I'm going to hope it doesn't shift on me, but there's no guarantee. Okay. My maximum is at negative 1.64, negative 1.64, and 7.86. Now I'm going to go to my graph and try and graph that. Negative 1.64 and 7.86. So I go negative 1.64, and then 1, 2, 3, 4, 5, 6, 7.86. So like here. Now if it's a decimal, I'm going to label it. I'm going to put what the coordinate is above it. And I'm putting it above it because it's the maximum. If I put it below, I'm going to be drawing my graph through the coordinate that I'm writing. So I'm going to write it above so that anyone marking this knows what that coordinate is. And it is negative 1.64, comma 7.86. And I would be doing this in the same color. So I have that coordinate. Now what do I need to find? The minimum. Let's try it out. Second trace minimum. If you're not drawing the graph like I'm drawing it, you're not getting full marks, just so you know. Second trace minimum. If you're just winging it off the screen, that's going to get you no marks. So I need the minimum now. Left bound, enter. I just need to be on the left side of it somewhere. Then I need to be on the right side of it somewhere. Then when it says guess, I just hit enter. And now I get 0.305, blah, 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 and 0.5138. So I'm going to round that to 2 decimal places too. So I'm going to go down here. And I'm going to write my minimum at 0.31, 0.51. And then I go plot that. 0.31 and 0.51. And I'm going to label it down here, 0.31, 0.51. Okay, then I need more coordinates. How do I get more coordinates? Second graph. I can go second graph. I'll show you even more places where you can get them. So I'm going to go second graph, and I can pull any of these. So I'm going to go -3, -8, -2 and 7, -1, 6, 0, 1, 1, 4. Those are the only ones I can put because my window is set to those. So that's what I'm going to put in. So I'm going to go plot those. So I have, okay, so I'm going to go -3 and -8. And normally this wouldn't have to be, the dot wouldn't have to be stated what it is because we're going to have an actual graph. It'll cross right through a section. And then we have -2 and 7. And then we have -1 and 6. And then we have 0 and 1. And then we have 1 and 4. Now, don't connect them yet. Do I have every possible point I could have? Do I have enough points? Could I find more points? Like if I'm drawing this one here, I'm just going to sketch it. I don't know if it's going completely up. And there's really no point between this one and this one. I'm just kind of randomly sketching. I can get the x-intercept. How do I find x-intercept? I want to calculate something, so what am I going to do? So I'm going to go y equals, so if I want, I can go second, calc, and I want to find the x-intercept. Well, x-intercept isn't on there, but there's other words that mean x-intercept. What other word means x-intercept? The 0. Zeros, roots, x-intercepts are all interchangeable words. So we're going to find the x-intercept by pressing number 2, which is 0. Now I need to be left bound of the x-intercept. Here's my x-intercept. If I drew a vertical line through it, am I on the left-hand side of it currently? No, I'm on the right-hand side. So I need to arrow over. Am I on the left-hand side yet? Here's my x-intercept, this dot right here, right? I need to be on the left-hand side of it. I need to be down here. That's on the left. That's on the right. So I need to get down here. This is left. Enter. Now do you see it's actually drew a line on the left of it? And I need to go on the right. Now it drew a line on the right of it. And then I press enter. If you pick the wrong spots, it will just error you. Now if you look, mine is nice. Mine is at -2, -2.64 and 0. Can everyone look at their calculators? A lot of you, I think, have like 1.4 times 10 to the -12 or something like that in front of your faces. Everyone's looking? It has an E, right? It has like 1.4 e to the -12, I think, or something like that. All that means is that scientific notation for 0.00000000000014. What can I round that to? 0. Whenever you have e to the negative anything, do you see it? Everyone needs to spot it. When you see e to the negative anything, that immediately tells you that number is 0. That's just scientific notation for a whole lot of zeros and then that number, which we round to 0. Okay? So if you ever see e to the negative anything on your calculator, that is 0. So mine went to 0. Yours is e to the -12. That meant 0.011 zeros and then a 1. Same thing. It's at 0. So I'm going to plot that. -2.64 and 0. Now, what if I want points in between? What if I want more points? Well, my table of values just gives me integers because that's what I have it set to do, right? But I can find any x in between. What if I want, what's the y at 0.5 when x is 0.5? Follow along. You go second, calc, and now I can get any x I want. I go second calc value. Now here's x equals. I can put in any x I want. It will pop out any y I want. So say I put in 0.5. Now I could plot 0.5 and 0.75. So it's like here. What if I want some more? What if I want second trace value negative 1.5? Well, that's at 7.75. What if I do negative 0.5? That's at 3.25. So negative 0.5 is at negative 3.25. You see how I'm just getting more coordinates? And the more coordinates you get, the more accurate your graph is. We agree? So now we're going to connect them. They need to be rounded. Please don't draw it as like a mountain with a peak. And these need to, mine would not get full marks. I'll tell you that right now. This would. My way I'm going to start drawing now, because on this board I cannot make straight lines if my life depended on it. I'm not going to get a full mark for what I'm going to draw you. Forewarning you right now, it's very hard to do. Maybe I will, now that I said that right now. So you draw your line, and you're trying to connect them perfectly. See, I'm already curved. Draw it up, and then it curves. That's terrible. Draw it down through here, and it curves. Yours should look better than mine, because mine is going to be a little bit wonky, just solely due to the fact of drawing on sport. Now you should have arrows on the ends of both of them, correct? This graph goes on for life. There should be arrows on the ends. What is the leading coefficient of this graph? What's the number that leads it? 2, positive 2. Do we see that? I don't know what you're doing. Positive 2. If it's a positive 2 leading coefficient, what does that tell you?
I don't know.
So, if we have a positive leading coefficient, we know it ends up on right. So this one ended up on the right. We agree? Because it's a degree 3, we know it ends what on the left then? Down. Because they're opposites. They disco, right? So this is up on right. Because it's a degree 3, I then know that it is down on left. Board makes my handwriting so terrible. Okay. What is the y-intercept without using our calculator? What's the y-intercept? 0, 1 because of our constant. This board just moved on. Okay, so this here's my y-intercept. So it's at 0, 1. How many x-intercepts do I have? How many x-intercepts do I have? I have 1. Does every cubic only have 1? No, it could have 1, it could have 2, it could have 3, right? Those are our options. Now, if I wanted to find the y-intercept using my calculator, what are you going to do?
What?
Where's your phone?
My bag.
All right. If we want to find the y-intercept using our calculators, that are just calculators, what we do is when we want to find our y-intercept, what does x equal? 0. And we know how we can type in x. So we go second trace value, x equals 0, enter. And it would be 0, 1. Want to zip it shut, maybe?
I was just.
I just can't even. Good. All right. What is the domain of a cubic? set of x values such that x is an element of the reals. What's the range? The set of y values such that y is an element of the real, because it discos, right? There's some funky stuff in the middle, but it still discos. So it's going to be. Did you see that? Anyone else? It's like there's a ghost in here or something. I'll take it. Whatever. I can write at least. X such that x is an element of the reals. And then y such that y is an element of the reals. Now I talked about turning points with you, and I said that the max and mins are turning points, correct? A point of inflection is just a curve, it's not a turning point. So this previous one had 0 turning points because it had a point of inflection. This one has a max and a min, so how many turning points does it have? The end behavior is just how it ends on the right and the left. So this one here ends up on the left, down on the right. This one ends down on the left, up on the right. That's your end behavior. Okay, it's just how it ends. And that's based off of your leading coefficient. Okay, so degree 3 functions will either have 0 turning points or 2. They can have a minimum of 1 y-intercept, 2 or 3. They max out at the degree. They min out at 1 when they're an odd degree because they disco, right? The main range is XER, YER unless it is a word problem, because it could limit your, if it was like volume, let's say, you can't have negative volume, and if it was X was your height, you can't have negative height, right? So you'd have to start at something greater than 0. Your homework is on Google Classroom already. It's only 3 questions, and if you finish them before the end of the class, which you should, because it's literally only 3 questions, you can show it to me even before Monday. We can get it done even now. I posted it in Google Classroom, but I will write it here in case you want to take a picture yourself. You don't want to use my scanned photo. It's page 288. Shh. That doesn't even look like 288, but it is. Numbers 7, A, C, and D. Literally just asking you for all the same stuff.